Let the g of x be this function sine cubed plus x cubed. The domain of this function g is the set of the real numbers, and we have a subinterval minus 2024. 2024 is a subinterval in the domain of the function g. We want to show that the integral on this interval is equal to 0. This can be written equivalently as the integral from minus 2024 to 0 plus the integral from 0 to 2024 of the function g. I stop right here. And I consider this integral here. Let's call it I. I call this integral I, and I change variable. U equals minus x, du equals minus dx, and from here the differential dx equals minus du. I also change the bounds of integration. Is 2024, and here is 0, sine cubed of minus u plus minus u cubed, and dx equals minus du. I flip these numbers, so I kill the sign minus here. Integral from 0 to 2024, sine cubed of minus u plus minus u cubed du. This can be written as minus sine cubed of u minus u cubed du, or this I can pull minus 1 outside and have inside the integral sine cubed of u plus u cubed du. I can flip back to my variable x. Now I go back and this is minus the integral from 0 to 2024 sine cube of x plus x cube dx plus the integral from 0 2024 sine cube of plus x cube dx. And this gives me 0. in order to derive the result here, when I chose the integral I, these two functions are odd. The sine u is an odd function. Sine is an odd function. So the sine of cubed of u is also an odd function. U cubed is an odd function. So this minus appears here in this integral minus the integral from 0 to 2024. So I have exploited the fact that these two functions are odd. So the sum of these two functions, the function would be odd. And as a consequence, when I go back and compute my integral on the interval delta, using the previous properties, I deduce that this integral over the interval delta is equal to 0 of the function g. I could have saved more space if I have had a question before showing that g is an odd function in the domain, and then this would be easier because first I could show that g is an odd function and then just change variable here without substituting, these functions inside the integral here. And this could be shorter. Anyway, the approach is this one. You exploit the fact that you have the sum of two odd functions is also an odd function. Then you split the integral from in two integrals, and one interval from minus 2024 to 0 and from 0 to 2024. You choose the first integral and you change the variable, and then go back and substitute and get the desired result.